Welcome back to the second day of Chapter 6, specifically the first section, which is operations with polynomials. This is a continuation of what we did yesterday. So look at what we're going to do today. First, we're going to determine the degree of a polynomial. We're going to simplify polynomial expressions, and we're going to multiply polynomials. All of this you've done before, so it should be a review. For the ACT, you have to be able to apply the rules of exponents and add, subtract, and multiply polynomials. Again, all of which we're doing today. First thing, determining the degree of a polynomial. Here's the rule. The degree of a polynomial is the highest monomial degree. So there's an example below. If we look here, we have x to the fourth, y to the third. So that's kind of like a seventh power. Here we just have x to the fifth. 7 is higher. So we say that the degree is 7. Looking at this definition, though, it says the highest monomial degree. So before we go on classifying, I want to talk about what is a monomial. Okay, so a monomial has no negative exponents, no square roots, and no division by a variable. If I'm moving too fast, please make sure you pause the video so you can write everything down. So I have a list of examples there. And I want to know which of those are monomials. First one, not a monomial, because it has division by a variable. Second one, not a monomial, because it has a cube root. This one, yes, is a monomial. Last one, no, not a monomial, because we cannot have negative exponents. Okay, so here are examples 1 and 2. Determine whether each expression is a polynomial. If it is, state the degree. First example has a square root of x. So this is not a polynomial. Okay, a polynomial just means it has many monomials. Because the square root of x is not a monomial, this cannot be a polynomial. Second one, yes, this is a polynomial. We have no square roots, no division by variables, no negative exponents. So now we need to state the degree. Here we have x to the third, y squared, so that's like an exponent of 5. We have 2 and 5, that's an exponent of 7. Here we don't have any variables. 7 is higher than 5, so we say that the degree of the polynomial is 7. Okay, pause the video right now. Here are 2 examples for you to try. Try them, and then come back and play the video when you're finished. Okay, hopefully you had a chance to try. First one, yes, a polynomial. The degree is 7 again. That's just a coincidence. It doesn't always happen to be that way. Second one, not a polynomial. That's because we have negative exponents. Okay, so that was classifying, or not classifying, well, classifying by degree, I guess. Now we're going to simplify polynomial expressions. Again, this should be a review. Here's the first one. First thing I want to do is distribute that 2. So I'm going to rewrite this first polynomial. You don't really need those parentheses, so I would just get rid of them so that they don't confuse you. Multiplying by 2, we end up with negative 8x squared, positive 18x, and negative 10. Now we need to combine like terms. We have x to the third. That's the only x to the third, so I'm going to rewrite that. Then we have this x squared over here, only x squared, so I'm going to rewrite that. I have a negative 7x and a positive 18x. So negative 7 and positive 18 becomes positive 11x. Last thing, I have positive 8 and negative 10, which becomes a negative 2. So this would be our simplified expression. It's customary to write the monomials in decreasing degree or in decreasing exponent, which is why I did x to the third, x squared, x. If you write it in a different order, though, that's fine. Sorry, little technical difficulties. Here's the example for you to try. So pause the video, come back when you're ready to try it. Okay, hopefully you actually paused the video and had a chance to try this one on your own. Now we're going to go over it together. First thing I would do is distribute this negative. So I'm going to rewrite the first set of parentheses. Negative negative x becomes positive x. The one that most people forget is to multiply negative by 1, which becomes negative 1. I need to combine those two like terms. It becomes 3x squared, add x, subtract 7. Okay, that's it simplified. Don't try to factor, don't try to solve. That's your final answer. Okay, last thing, we're going to multiply polynomials. Again, this is a review, so we should hopefully remember how to do this. Okay, here's example number 7. I'm going to show you 2 ways to do this problem. I'm going to show you the way that I prefer, and then I'm going to show you another way also. Okay, so those of you who have had me before, or maybe your other teachers have shown you this, I always make a box. Okay, so my box is 3 by 2. On the top, I'm going to put x squared, positive 4x, positive 16. Here I'm going to put x, subtract 4. This is a way for me to organize my work so I don't get lost. X multiplied by x squared is x to the third. X multiplied by 4x is 4x squared. And then I have positive 16x. X squared multiplied by negative 4 is negative 4x squared. And we have negative 16x and negative 64. Ooh, sorry for writing down there. Okay, now I need to combine like terms. This is my only x to the third. I have 4x squared, negative 4x squared. That just becomes 0x squared. I have positive 16x, negative 16x. That becomes 0. And then I have negative 64. So that's my final answer. Again, that's the way I prefer to do the problem because it's a good way for me to organize my work. Some of you draw these arcs. So x squared multiplied by x is x to the third. And then we have negative 4x squared. And then we have positive 4x squared. Negative 16x. Positive 16x, and then negative 64. So again, we see negative 4x squared, positive 4x squared becomes 0. Negative 16x, positive 16x becomes 0. And you're left with x to the third, subtract 64. So again, you're going to get the same answer either way. It's up to you which method you would like to use. Again, box is a good way to organize your work, but if you can do it with the arcs, totally fine. Okay, so moving on, this is our last example. Pause the video right now. Try this one on your own. When you have a complete answer, come back. I will show you how to or how to solve the problem, I guess. So you can check your answer. You may use the box method or the arcs. Okay, hopefully you had a chance to try this one on your own. We're going to go over it together. Again, I prefer the box method, so that's what I'm going to do, so I make sure I don't lose anything. Okay, so this becomes 6x to the third, negative 12x squared, and positive 15x. This becomes negative 2x squared, positive 4x, and positive 5. Now I'm going to combine like terms. That's my only x to the third. I have negative 12x squared, negative 2x squared. That becomes negative 14x squared. Remember, the exponents stay the same. Then I have this 15x and this 4x, which become 19x. And then that 5 is the only constant term. So that should have been your final answer. If you used the arcs, you should have gotten this as your final answer as well. Okay, so this is what we did in this video. We determined degree. Remember that a polynomial has no negative exponents, no division by a variable, and no square roots or cube roots. We simplified polynomial expressions, and then we also multiplied polynomials. So when you come into class, we're going to go over some problems involving these three objectives. Goodbye.